Hello, Lakers. Welcome to today's lesson. Today we are going to look at three-dimensional distance. And in Desmos, please share how you're feeling. Which duck matches how you're feeling today? For me, I'm a little worried, I'll be honest. And you are welcome to check answers of previous students and yourself. Again, we're going to review distance in 2D, 2 dimensions, and then use that to apply in a 3-dimensional space. First, build your confidence in looking at 2-dimensional distance. Think about which one is longer. And here you're also comparing lengths. Think about using the grid to help you. Which one appears to be longer? And think about how we have used distance in the past. For example, we could use right triangles to find distance. And think about the dimensions of these two triangles. Here we have 3 and 3. And then in the blue, we have 1 space here and 4 spaces here. Well, in this case, the red is longer. And the reason is because 3 squared, I'll show you how to use this calculator. 3, and if you minimize your screen, you can see the keyboard. So 3 squared plus 3 squared, that equals 18, 9 plus 9. And then notice in the blue, we have 1 squared plus 4 squared. Well, that's 1 plus 16. That's equal to 17. And 18 is definitely bigger than 17. And so that red is larger. Okay, so here's a review of how you can calculate in Desmos. Remember that square root symbol is in the keyboard on the left, and you can also use a to the second power to raise things to the second power. Apply your knowledge of distance. So notice this orange point. We want to create the distance from the origin. So there's 3 spaces down, 4 spaces to the left, and that is the direct distance from the point to the origin. So when we are calculating, remember we need to take the square root of, and let's look at these distances again. Here we have 3 and 4. So we have the square root of 3 squared plus 4 squared, and that gives us 5. Success. So keep building your confidence in this 2-dimensional space. Go back and check your answers when you're done. The last one shows you the coordinates on the graph. I encourage you to draw the triangle. Now, let's remind ourselves of 3-dimensional space. Looking at these coordinates, notice that P goes out 2 spaces on the x-axis. And then, to get to this point, that is 3 spaces on the y-axis. And then, vertically up 1 space on the z-axis. So we need to find 2, 3, 1. There it is right up at the top. 2 spaces on the x-axis, 3 spaces on the y-axis, and 1 space up on the z. Now in this first practice, think about which relationships show this distance. Here we have 2, 3, and 5 as the coordinates of P, and that is 2 spaces on the x-axis, 3 spaces on the y-axis, and then 5 spaces up on the z-axis. So which arrangement will help us find that distance? I'll tell you, the first one is correct. 2 squared plus 3 squared plus 5 squared will give us that distance from P to 0. But there are 2 other relationships that I encourage you to find and check your answers. Next, find the distance between P and Q. And so what we want to do is take the square root and find the difference between the x coordinates, the y coordinates, and the z coordinates. So 4 minus 2 after the square root, close that parentheses, squared. Then we have negative 2 and 3 plus negative 2 subtract 3 squared plus 3 minus 5. Now, I want to emphasize that we could have also done 2 minus 4 or 3 subtract negative 2 or 5 subtract 3. It would get us the same distance. In fact, I'm going to copy that and I'm going to explain it down here. Oops, get out my keyboard. 2 minus 4, and then 3 minus 2, or negative 2, excuse me, and then 5 minus 3. That is going to be the same 5.74, because look inside the parentheses. What's 4 minus 2? 2. What's 2 minus 4? Negative 2. Take that negative 2 and square it. Take that positive 2 and square it, and you get the same value. So the order of the x's does not matter. The order of the y values does not matter. The order of the z values does not matter. You will get the same distance. Just make sure to follow the Pythagorean theorem. We square it, square that difference, and then take the square root at the end. Do the same for segment AB, and then apply that distance of Pythagorean theorem to a 3-dimensional box. In number 5, you are looking at this top point. We call that the apex or apex of the square pyramid. And you can click on this link to see the full problem. You can determine whether this is directly above the center of our square base. And then you're going to find the volume. Remind you that the volume is equal to 1/3 area of your base times your height. And then find the coordinates of the midpoint. Find the length of the midpoint up to the apex. So you're going to find this distance from M to D, which ends up being the height of the triangle on the surface. So the last application you'll do is the surface area. You have 4 triangles and 1 square to compose that pyramid. So think of the area of your base and then the 4 triangles around the pyramid. Your height is the distance that you found in part D. The last practice looks at two airplanes that are in the air, and they are a certain distance from a tracking station. And the tracking station is at the origin. So we need to determine the distance between the two aircraft. How far are they apart? Notice this map or this graph appears to be close, but they really aren't that close. They're in space. How far are they? Then we're going to look at the distance between the aircrafts and where the tracking station is. Lastly, the tracking station only has a range of 40 kilometers. So if we had a radius of 40 kilometers in all different directions, that 40 kilometers, will that 40 kilometers reach the aircraft? And then think, why is that an important question for us to answer or consider? All of the solutions are in the PDF in this post in Google Classroom. Please check your answers and please go back and correct any mistakes before you leave Desmos. Lastly, you are going to rate your confidence. If you'd like to say more, feel free. Otherwise, just put a period, submit, and then make sure to finish projects and complete any missing work. Have a great day.